In this video, we're going to look at the properties and reactions of group 2 metals you need to know for AQA A-level chemistry. This is a revision video. For more detailed explanations about the content covered, please check the links in the description below. Atomic radius of the group 2 metals increases down the group. The atoms get larger. The first ionization energy of the group 2 metals decreases down the group. This tells us that it gets easier to remove an electron from an atom of each metal as you go down the group. As a trend, melting point decreases down the group due to weaker metallic bonding. Magnesium is an exception to this trend. The reactivity of the group 2 metals increases down the group, meaning they more readily form ions with a 2+ charge. They form ions with a 2+ charge as they lose their 2 outermost electrons from an s subshell. This trend in reactivity can be seen by looking at the reactions of the group 2 metals with water. When a group 2 metal reacts with water, a metal hydroxide and hydrogen gas gets formed. The general reaction is metal plus 2H2O forms MOH2 plus H2. Magnesium reacts very slowly with cold water to form MgOH2 and H2. The reaction is slow due to insoluble magnesium hydroxide being formed that inhibits water from reaching further solid magnesium. Magnesium reacts quickly with steam to form MgO, magnesium oxide. Calcium reacts steadily with cold water. Strontium reacts quickly with cold water, and barium reacts rapidly with cold water. The reactions become increasingly vigorous as you go down the group, showing an increase in the reactivity of the metals. The solubility of group 2 metal hydroxides increases down the group, with magnesium hydroxide, MgOH2, being only sparingly soluble and strontium and barium hydroxides being highly soluble. This means the metal hydroxides more easily split apart and dissociate in solution, releasing a metal ion with a 2+ charge and hydroxide OH- ions. As a result, more soluble metal hydroxides produce solutions with a higher pH. As the higher the concentration of OH- ions in a solution, the greater its pH. This means solutions of the group 2 metal hydroxides become increasingly more alkaline, a higher pH, as you go down the group. Group 2 metal hydroxides can neutralize acids, which can be useful. For example, magnesium hydroxide, MgOH2, is used in medicine to help neutralize excess stomach acid and raise the pH slightly in a person's stomach. Calcium hydroxide, CaOH2, is also used in a similar way in agriculture to raise the pH of soils that are too acidic. The solubility of the group 2 metal sulfates decreases down the group. Group 2 metal sulfates are made up of a metal ion, M2+, and a sulfate ion, SO4 2-. Magnesium sulfate, MgSO4, is highly soluble in water, whereas barium sulfate, BaSO4, is insoluble. The insoluble nature of barium sulfate enables it to be used in medicine. Being a metal, barium shows up well in an X-ray. The only problem is it's highly toxic when ingested. Because barium sulfate is insoluble, however, the barium is trapped in the sulfate compound and cannot do any damage to a patient's body. A patient can ingest barium sulfate, and when X-rayed, we can see where the barium sulfate is in the patient's body. This can help identify digestive disorders. The insoluble nature of barium sulfate also allows sulfate ions in solution to be identified by adding aqueous barium, Ba2+, ions. The barium ions combine with the sulfate ions, forming barium sulfate, BaSO4, which, because it's insoluble, shows as a white precipitate. The barium ions are added from a solution of acidified barium chloride, BaCl2. The solution must be acidified to ensure any carbonate ions present in the solution are removed. Otherwise, they would also combine with the barium ions, forming barium carbonate, BaCO3, also a white precipitate. Meaning if a white precipitate formed, you wouldn't know if it is from sulfate ions or carbonate ions. A more specific use of the group 2 metal magnesium is in the extraction of titanium from titanium 4 chloride. As magnesium is more reactive than titanium, when it is heated with titanium chloride, the magnesium gets oxidized and forms Mg2+ ions, whilst at the same time the Ti in the titanium 4 chloride gets reduced from an oxidation state of +4 to 0. This results in titanium and MgCl2 getting formed. TiCl4 plus 2Mg forms Ti plus 2MgCl2. The MgCl2 is soluble in water, and this means it can be separated from the titanium in the mixture. The titanium is actually found naturally as titanium 4 oxide, TiO2. This oxide is heated with chlorine gas and carbon to form the titanium 4 chloride that is then reacted with magnesium in the extraction process. TiO2 plus 2Cl2 plus 2C forms TiCl4 plus 2CO. Calcium oxide CaO and calcium carbonate CaCO3 can be used to remove sulfur dioxide SO2 from flue gases. The sulfur dioxide is formed from the combustion of sulfur-containing fossil fuels and can lead to acid rain. Calcium oxide is sprayed as a slurry into the exhaust gases and reacts with sulfur dioxide present. Carbon dioxide is also produced if calcium carbonate is used instead. CaO plus 2H2O plus SO2 forms CaSO3 plus 2H2O. And for calcium carbonate, CaCO3 plus 2H2O plus SO2 forms CaSO3 plus 2H2O plus CO2.